Hello, and welcome to the second installment of the 2022 Legends of Simpson lecture series. We're so excited that you're able to join us today, and we're very excited to welcome Dr. Ron Warnet as he discusses the future of science. Please help me in welcoming Dr. Ron Warnet.
Well, the applause is overwhelming, actually. I don't hear a dang thing. But I'm very happy to be here this morning, mainly because this topic has intrigued me for quite a while. I've been thinking about the future of science because I sort of know something about its past, but its future, of course, is still up for grabs. And so I want to say, first of all, say that I'm Ron and I'm a chemist. Most of you know that, I suspect. But the most usual response I get from that acknowledgement is, oh yeah, that was my worst class in high school, and then silence. Some people even walk away and turn to talk to somebody else when they hear that. This response has taken a toll on my mental health over the years, and you'll see that, I'm sure. About a month ago, I was introduced to a prospective student here in the library, which is where I'm spending my retirement, apparently. And she responded to my declaration that I was a chemist. She said, "Me too, I love chemistry." And my response to that was probably inappropriate. I said, "That's wonderful, can I give you a hug?" And luckily she agreed, because probably I was already starting to hug her, no matter what her response would have been. I also grew up in a family and at a time when science held such promise for a better world. We had just come out of the Second World War. And during that war, penicillin was developed as the first antibiotic that really took hold. And it led to the, it was discovered, by the way, in a cantaloupe, the mold on a cantaloupe in the supermarket in Peoria, Illinois, because that's where the USDA had a lab and they were working on that. Some of the antibiotics have come from strange places, such as that cantaloupe. But it brought promise that the world could now not be at the mercy of bacterial infections. And it ended up with a first for a war. It was the first war of any magnitude in which more people died of bullets than they did die of infection and disease. I'm not sure that's a good outcome. I wish people wouldn't die from bullets too. But it showed that we could fight back to what had been previously a rather mysterious disease, set of diseases. A little while later, well, many years later, because it was fairly recent, a faculty member, actually a staff member here at Simpson, asked me a question. She asked me if I believed in evolution. And I said to her, no, I don't believe in evolution, because science is not the result of belief. It was the best explanation that fit the evidence of how the world came to be, and particularly how living things came to be. We've tested it through experiment and it held up. And she replied, I never thought of science that way. I think a lot of science has never been thought of in the way it really occurs, and maybe I can dispel some of that today. In 1939, Wallace Carruthers, you all remember Wallace, right? He's a chemist working at DuPont, and he developed nylon, which had one property that was really helpful to society, and namely, that was its strength. It was very strong and could be made, because of that strength, into very, very thin fibers that held up. And it became a wonder fabric when you wove it. It mimicked silk in the way it felt, and the whole women's stocking industry was changed, because the silk, because of its inherent strength, would hold up better than silk would. That strength also allowed it to be transformed into rope strong enough to tow ocean liners, and it did not rot when wet like hemp did, which was the previous winner of the rope contest. Plastics were discovered, and now we can hardly buy anything that is not wrapped in plastic of some kind. It's really a wonder. I became aware of this because of our last guest, which was, see, I'm having trouble with names, Jan Everhart, and that's why I asked that question last week. If you go to the store and try to buy fruits and vegetables, which have their own packaging called their skin, Hy-Vee wants you to wrap it in plastic. And if you don't wrap it in plastic, they will give you and wrap it in plastic at the exit door when you're going through the checkout line. Most everything is packaged in plastic these days. As a matter of fact, I challenge you to buy something at Walmart that's not in plastic. This week, just keep track of what you buy and count up the percentage that does not involve plastic of some sort. It is almost zero. I'm considering actually of taking whatever I buy out of the plastic container and returning that to the store, the milk carton, the pill bottles from the pharmacy, the electronics wrapped in shrink wrapped or something or other in plastic, and let them worry about it and see how they like it. But since that discovery by Wallace Carruthers, ways have been developed through a new field of science called material science. We've had some students go to graduate school in that field, which we've been privileged to be able to make materials with any property we desire: heat resistant, stain resistant, scratch resistant, fade resistance, substitute for bone, skin, hearts, arteries, hair. We don't have to endure problems, we can eliminate them, or so we thought. The Salk vaccine in 1954, when I was probably in 8th grade or something like that, brought an end to the overwhelming fear many parents, including my own, had that their child would get polio and become disabled or even worse. It was developed because we understood that polio was a virus and therefore antibiotics would be ineffective. There appeared to be no end of diseases science could cure. In 2020, Smithsonian Magazine ran an article entitled 10 Trends That Will Shape Science in the 2020s. So I thought, well, I should read that list because that sounds like it will be helpful for this talk. And there's an impressive lineup of all sorts of things, including many space missions to Moon, to Mars, to even to asteroids, one of which looks like now could collide with the Earth in the 22nd century. Japan is planning a series of shots to send projectiles to Mars and the Moon and then return to the Earth with samples. Another area is batteries. We've been working on batteries for a long time and we haven't progressed very far, but all of a sudden now with lithium ion, and I hear sodium ion batteries are on the future, are being used so they can be shrunk in size and weight and still store immense charges. You can now buy a solar system for your roof with batteries so you can disconnect yourself entirely from the grid. And in the field of drugs, we have better drugs for the control of cancer and pain, therapies effective for control of addiction, PTSD, Alzheimer's, depression. Better custom design therapies now are starting to come out by analyzing your DNA and seeing what you might be allergic to or how you might react to certain drugs, because we all react differently. One of our former students, Stephen Hendricks, some of you may remember, as part of his PhD thesis at Northwestern, developed a way to package anti-cancer drugs for prostate cancer in a layer of lipids which prevented the drug from reacting with non-cancer cells. There was a trigger on the surface of the lipid, so when this lipid package came in contact with a prostate cancer cell, it would open up and release the drug. This has the promise of lowering the amount of side effects from anti-cancer drugs. So a chemotherapy is kind of promised now with almost no side effects. And this would be remarkable. And that drug from him is now in trials. Science is hot on the trail for novel drugs and drug therapies for all sorts of diseases. We used to develop drugs in a very different way than we do now. We used to develop them by finding some plant, usually a plant, which is no mistake, because plants have different chemistries than animals do, and so can disrupt some of the things that cause disease in animals. But those plants used to be suggested by Native Americans and other native tribes who have used them to control fungus or whatever. Aspirin is a good example of that. That was developed from Native Americans in this country who chewed on the bark of the willow tree to get rid of pain. And what was in the willow tree but was an acid that we now turn into salicylate and used for aspirin. So aspirin came from our Native American population. At one time, there were ships filled with the bark of willow trees, which grew in America, off to Europe because they had pain there too, as a matter of fact. Since then, we've gone on to things like vaccines, which can handle viruses, as opposed to our antibiotics, which handle antibiotics. And a vaccine for COVID would be nice because that would solve all of our problems if only people would take it. Medicines are now being developed to slow or stop memory loss in Alzheimer's, even to possibly recover lost memory due to that tragic disease. These are some of the things that I want you to watch for on the horizon, thanks to some new science. But there are other issues that will shape the future of science that are also on the horizon, or in some cases already present. You have, I am sure, noted the rise of a serious distrust of science in this current pandemic. Right now, this distrust has spread through every level of society. Many public and private school systems around the country wrestle with controversy over teaching science and see evolution as a threat. Here in the United States, significant segments of our society have not embraced the vaccines developed in response to the current pandemic, despite the overwhelming scientific evidence of their efficacy and safety. I have struggled to understand this turnaround in the public's faith in science from the 1950s. This loss of confidence in science has been building for some time, but this pandemic and the increasing reality of climate change, among other things, has thrust humans into a scary new world. We seem powerful beyond our wildest dream to affect planet-wide damage to the environment, and yet we seem as equally powerless to do anything about it. We thought science could save us from anything this world would throw at us, and we have been disappointed, disillusioned, and frightened, and it now seems we could ruin this planet ourselves for the possibility of life. Misinformation is rampant, and there is widespread misunderstanding about how science works. The poor person giving us the weather forecast is roundly criticized if they're off by an hour with their forecast for when the rain will start. They are never right, people say. We can't rely on them, when in fact, they are very reliable. They are now giving 12-day forecasts that are quite reliable. Yes, the rain doesn't come at the very precise hour they said, it comes a half hour later. Big deal. Every person thinks they know science better than scientists do, and that's getting in our way of benefiting from science. The CDC keeps changing its recommendations about masking, and I just don't think they know what they're doing. Well, they know very well what they're doing. There's no such thing as 100% in science, even though people sort of come to expect that. For instance, in drug use of drugs, every person reacts differently to drugs because I'm a different person than any other person on this planet. My DNA is different and probably holds the information to tell scientists how I will respond to new drugs. But the CDC, back to them, is getting new information every day. So the course of recommendations for a brand new disease like COVID are going to change. We'd be remiss not to change them because new knowledge is gained every single day about COVID. Our understanding of this disease is growing daily, and we should change our response. This is how science works. But the public doesn't seem to understand. Good science takes time. Shortcuts lead to false data and false conclusions. Some of you may remember, a number of years ago now, thalidomide was a drug that was developed to help infertile couples have children. And it was approved in Europe, but not in the United States. And the public just clamored for that drug because it would help so many people who desperately wanted children. And then we discovered that it had a flaw. And we had thalidomide babies that were missing limbs because it not only helped people get pregnant, but it also interfered with the genetics of the newborn. And so we averted a terrible tragedy in the United States because we had the CDC and the FDA monitoring that, and they knew that they didn't know enough to be sure that it was going to prevent disease, and it didn't. And I've always thought about that example and been thankful, because I've seen some people who have had the results of thalidomide in their children, and it is no fun. But challenges to science are growing. It's more complex, which is another big issue, I think, in the current distrust of science. Most of us will remember, particularly alums, when it was much simpler. Remember dial telephones and party lines? When I moved to my small farm outside Indianola, almost 50 years now, I was on a 10-party line. I had to wait my turn, but I did know my neighbors by name and voice. And what about cell phones? Need I say more? They are very helpful, but they're more complex. And for many people, my age particularly, they're too complex. We're looking for simple stuff. My finger doesn't fit on the top of the cell phone that I only hit one number when I poke it in. And my thumb is certainly too big for that. The same thing has happened in science. When I went to college, the atom, as described by Niels Bohr, the famous Danish physicist, was quite understandable. Electrons were like planet, and the nucleus was like a sun. I understood that. That was my understanding of atoms when I arrived at college. But before I left college, electrons were best understood as waves of energy, not like planets at all, but now only probabilities of where they might be, not distances and distinct positions. And they had the dual properties of both waves and particles. That was much harder for my mind to grasp. Now it's sort of commonplace. But that's how science changed just in my 4 years in college, and that has accelerated. And right now we have a very interesting experience in the acceptance of science by the public. We have the Webb telescope, which I'm very excited about because I've always been interested in astronomy. My parents, when I was like in 7th grade, gave me a 3-inch reflecting telescope. And I thought I could see the world from, well, other worlds from there. My father was also interested in space because he had seen the first airplane go over, and now he was seeing the first satellite. When Sputnik was in the air, he drugged my brother and I up at every hour of the day and night, whenever the satellite, or really the booster rockets you could see, were going over the sky. And we would walk 2 blocks in the middle of the night, rain or shine. Well, it wouldn't be rain or shine. It was only when it was shining because you couldn't see it otherwise. But it could be cold or reasonably warm. And we walked the 2.5 blocks over to a recreation field where there was little light, and we laid the blanket down and we would wait for the satellite to go over. My mother did not get up. She didn't like this idea particularly. But my father took us up there. My brother and I were together at Christmas, and we were remembering those times of getting up there. But this telescope is now orbiting the Earth about 1 million miles away. It will see further into the universe than any telescope before. As a matter of fact, much further. You think you've seen things with the Hubble telescope. This is going to be remarkable. But when you see things at a greater distance into the galaxy, you're going to see back in time as well. And that's a hard concept for us, because for us, light is instantaneous. Sound is not. We know that comes much slower to us. And if you hear a bolt of lightning, if you see a bolt of lightning and wait for the noise to come, you can find out how long it is. Just count. And when you count to 5, that's about a mile. So 1, 2, 3, 4. And you know that lightning struck about a mile away. I still count every time I see a lightning strike. and wait for the following thunder. So there's a little bit of science in that, as a matter of fact. So when you look back in time, because light travels at a finite distance during time, and it's a finite speed, it will see back in time. It's estimated that the Webb telescope will see so far back in time that it will see back perhaps as far as the Big Bang. We will see light that was generated at the beginning of our universe. Let that sink in a bit. That's hard to conceive of. That's 4 billion light years away. And yet we will be able to see that. And when you see the light from a planet, you can tell, or from a sun or from anything, light tells you what the thing is made of. We know those are the ways of science. So we will be able to see the beginning of our universe from the Webb telescope. I think that's going to be a remarkable thing. Now, the question is, what is humanity going to do with that? It's not clear to me that humanity has the capability of putting that into our heads and thinking about that. So I'm interested to see that. And I probably will live long enough to see that, because we're starting to get results back from the Webb telescope. They've calibrated it now. They've seen their first stars. It's particularly amazing. A recent book that I've read by Ari Loeb, has been head of the astronomy department at Harvard. He's still working at Harvard. And he titled his book, Extraterrestrials, the First Sign of Intelligent Life Beyond Earth. Now, we've been thinking about extraterrestrials for a long, long time. It was the, still is the things that many people have written about and made movies about and thought about, both in terms of making money from the movie and also in terms of science. And Ari, in this book, argues that the probability of life beyond Earth is nearly 100%. Because given the immense number of stars and the planets that go around them, and we now know there's been about 1,000 planets that we have now seen of through our current telescopes around other stars, and we have some idea even about those planets having moons. And it looks like some of those planets, a good number of them, are in a habitable zone from their current sun. And we know that the number of galaxies in our universe approaches a large number, hundreds of thousands of galaxies and hundreds of thousands of stars in each galaxy. And so the probability of one of those having habitable conditions is pretty high. But he also argues another thing, which I find very disturbing and upsetting. He also says that we're unlikely to find intelligent life because intelligent life in the universe is self-limiting, because intelligent life inevitably causes its own demise. Given our current inability to control climate change and our appetite for large amounts but of limited resources, that seems reasonable to me. Now, I don't know what all that means. So I'm sorry, I have more questions than I have answers here. But that also is the nature of science, by the way. I remember when I was doing a year-long sabbatic at the University of Chicago, I was taking bits of pith from tobacco plants and putting chemicals on that to understand what triggered the growth of those quiescent cells into growth. And you could change whether they made roots or shoots by changing the ratio of cytokinins in that mix of chemicals. And I did this up in an attic of the science building at University of Chicago that was built back in the 30s. And it was a little warren up there that I had a skylight over me. You really couldn't see out. But across from where I was doing that was a room where plutonium was discovered. And I remember looking in that, there was a glass door on that room. It was sealed off because it was radioactive. I thought to myself, boy, that was a momentous discovery of an element beyond uranium. And I'm sitting right in the next room over here doing this. And the person I was working with, Dave Lynn of the University of Chicago, was my person I was collaborating with. And one dark Friday night, it was close to winter, so it was already dark. I was up there transferring the cells because you had to divide them and put them on new media so they could continue to grow. And you could see the roots on some and the shoots on others, and taking some measurements and whatnot. And it was tricky because it could easily become contaminated with bacteria and die off. But I had mastered that pretty well. And Dave came up just to see if I was still alive up there, I guess. And we just both stood there and looked at these undifferentiated cells that were growing into differentiated cells, changing the genetic, not the genetic makeup, but the expression of the genetic makeup by these chemicals that we were introducing. And it got quiet. We didn't say much for a little bit. And Dave said, I wonder how they do it. That is just amazing. And that's one of the things that science has continued to do for me. It's amazing. It's amazing what we can know. It's also amazing what we do with that, both good and bad. I hesitate to end here because there's a lot of things I don't know. What I do know is that when we give up on science, we lose our ability to understand the world around us and the truth of our existence. And if that happens, there is no future. What I do hope is that we can debate, argue, discuss, and think about this together, because as a human race, that is what we're going to have to do. We're coming to some points where we need to make some really big decisions about what we think and how we're going to follow, how we're going to educate our children into this world that's coming, benefiting from it as best we can and not destroying this planet. And it's a big challenge at this point. So we have time for some questions, and I would love to have questions. I always said to my class, I could teach a class just by questions coming from students, because then I know what they're thinking. So if you have some questions, that'd be great.
Well, first and foremost, thank you so much, Dr. Warnet. Very interesting, and we already do have a few questions coming in. So the first question is the future of science conditional? What are the conditions that make science with a future, or the future of science, or future science possible? I'm thinking of the notions of entropy or conservation, or how science is showing how we may be able to destroy any given condition instead of working within the limits of science to make a way onto the future of science.
Well, in that sense, I think there's several thoughts there. I don't know the answer, but science is self-limiting because we can't do with science what we can't do, what science won't allow us to do. So there is a self-limiting aspect to science. We thought that we could, by chemicals, change lead into gold. The alchemists thought there was magical potions that could be used, and that didn't work, obviously. We have changed lead into gold by bombarding lead with particles that would fuse with it and up the atomic number of it into the gold range. But we didn't do it by the way that alchemists thought we could do that. And we can't wish things to happen if the science doesn't say it can happen. So we wished for some things that science couldn't deliver before. It can't deliver eternal life. Not yet, anyway. So we have no way of doing that. I will die. Probably not in the distant future either, which is concerning because I want to see how this all comes out. So there are some limits like that to science. I don't think we've reached some limits that we think we have to science. But I do think there is some limits to what humans can understand. We are finite beings. And I worry about the complexity, for example, of cell phones or whatever. Now that's technology, I know, and there's a difference between science and technology. Science is the understanding of what is, and technology is an understanding of what we can do with it. But still, we haven't reached the limits of science, but there are limits to what it can do. It's limited to the physical laws of this universe, which we can't change very well. We sometimes think we're humans, we can do anything, we can change the laws of physics. No, you can't. Thermodynamics is the same as it used to be. So there are some constants there that aren't changing very well. I hope that sort of answers the question, but there's a lot more discussion on that question for sure.
Do you believe that the speed at which science is advancing also leads to some of the issues with people not believing in that science?
Yes. How's that for an answer? Yeah.
Pretty definitive.
The speed is an interesting problem because things are happening very fast. There's no question about it. The time that we went from the Niels Bohr concept of the atom to this wave particle duality was 4 years, basically. So there are times when science lurches ahead, and there are times when science is held back. So it doesn't go at a constant speed, but it seems to be increasing. And I think of this current pandemic, for example. We're in a very different world than we were 3 years ago. We have different understandings about how things work. We've used some old technology and some new technology. The DNA that was used to messenger RNA, rather, that was used to develop the current diseases is kind of a new technology. We knew about it, but we hadn't applied it before this particular pandemic. And yet that's proven to be some a good way to get to some very effective vaccines. So new challenges do bring on new science, and it's going fast. There's no question about that. And sometimes I think it's too fast for humans to sort of conceive of and work with. We all know people who refuse to use cell phones, for example, and seem to live moderately well with them. You know, they don't have to be in touch with the world 24/7. So yeah, I think there are some limits to science, and science will limit itself.
Another question here, Professor. What do you think about the effect of some social justice movements on science, in particular, some resistance to science if the findings don't support a political or social agenda? For instance, gender is a choice now, intelligence is not an inherited trait, etc.
Yeah, race is not real. For example, the idea that you can define people by their, quote, race, that's not biologically accepted in the scientific world. So I think science does have an effect on our understanding of each other, and how we understand disabilities, for example, and what people can do and can't do and all that sort of stuff. And I think we should pay attention to that. And we don't, because we like to hang on to the notion that somebody's not as good as I am. I'm better than some people. And we're all in this together. There's no question about it. And I've noticed really that people who can take that attitude do a lot better in this world. They're not fearful. They're accepting. I give credit to my mother, who only had an 8th grade education, but she loved it when I brought home students from college or other places with different religions or different countries they came from. I had a roommate from Iran for a year at Hope when I was there, and I brought him home to my family, and they had no trouble accepting that sort of thing. As a matter of fact, my mother would always, with people who she didn't know, would sit down by herself with them and try to learn something from them. And I'm grateful to my mom for giving me that openness to other cultures, because we are going toward a multicultural world where there's people of all sorts of ideas, all sorts of religions. And if we don't learn to live in that world, we will perish, I think. Just given the refugee problem in the world, which is only going to get worse because of climate, We've got to solve that problem of refugees. There's more refugees on the move today than ever before in human history. We've got to share this planet equitably, or we invite doom, because we invite conflict that way. It's been very helpful to me that I've been able to go around the world because of Simpson. I think I've taken 21 international trips with students around to every continent except Antarctica. And we've been in lots of cultures where we've learned about people's things. And some of the things we've learned, we found abhorrent. And we've had to readjust our understanding of that, because we knew people who followed that practice. That occurred in Tahiti when over the practice of giving your children away, for example. If you want to hear more about that, I'd be glad to talk about it. But that really upset our students. And because we thought no parent that loves their children gives them away. And it led us, and then we found the people we were working with and where we lived had all been given away. And they thought it was the greatest thing because they had more than one family. Sometimes you come up with stuff which just knocks you for a loop. And we've got to welcome those times, because we can learn from that. I don't know if that helps or not.
Yes, thank you. Another question here is, as a college biology faculty, I perceive that our greatest failure is our inability to capture the minds and imaginations of non-science people. You spoke of a time when this was different, e.g. the space race, end of polio. How can we as educators do better to combat the rampant disinformation that people turn to due to our institutional failure?
Well, that's a good question, and I've thought about that a lot, because I do think scientists can be arrogant about what they know and what they don't know, and dismiss people who have trouble understanding science. And I think we need to stop that arrogance. We need to include people and realize that people need to have an understanding of science that works better than the one now, because it's led to suspicion. That's not going to be helpful. We can be rather haughty people, scientists can, because they have power to do things which other people years ago thought was magical. So I think that's a very good comment, and we need to think about that here at Simpson, because we're a liberal arts college, and that means we include everybody. And we need a lot more discussions between people who are scientists and people who are non-scientists. We need to bring speakers on campus. We need to have classes in that area. We need to do a lot of stuff. We don't need people who simply stick, and this goes across the line, not just across science and non-science. We don't need people who stay in their little cocoon, because if we do, we get a misconception of what the real world is about. The real world is about all of us in this world. And we need to not only keep dabbing in that, we need to find that fascinating rather than scary.
This next question kind of ties into that as well, and speaking on how science is communicated out. And the question is, do you think that part of the distrust of science, besides a general lack of understanding of how science works, comes from those in the public eye not always sharing the bottom line honestly? For example, early on in the COVID pandemic, Dr. Fauci spoke about herd immunity and lowballed the amount of the population that needed to be immune before that was possible. Then the percentage kept rising in the public conversation, but science knew all along that it needed to be more than 50%.
Well, that's a complicated question, I think, because I think Fauci was probably doing the best he knew at the time. And that goes back to my comment about the ideas about COVID changing. It's been a disease that has come on us rather quickly. We didn't know how it operated. This idea of components on the surface of the cells, and my biologist friends know a lot more about it than I do, but has thrown us for several loops. And the different variants, we've known that we would get new variants. There's no question about that, because that happens with viruses. They mutate pretty fast compared to other things. And as long as they can replicate, they will mutate. And so we didn't control the replication very well, and so they mutated quite a bit. But that's part of trying to understand science. We're not omnipotent. Scientists are not omnipotent. They don't know everything. And so I do think we need to be as transparent as we possibly can. And that suffered during this pandemic because of all the different information that has come up there. So I would agree with the question, and I think we need to do better at that. No doubt about it. We got information. There's a lot of misinformation. We got information from some very unreliable sources, as well as some who were trying to be reliable. But the pressure on scientists to give absolute answers is incredible. I think of doctors who are bombarded with patients coming in and say, I heard on TV that this medicine was really good for this, and why aren't you prescribing it for me? And that's there because the pharmaceutical companies want to earn some money, so they put pressure on doctors by putting that information out. Go ask your doctor about this. And that's a very dangerous thing. Most countries don't allow drug companies to advertise on TV, whereas we've opened that up and we've suffered from that problem.
All right, we have time for a few more questions. And the first is, how can we best change our educational system so the base level of scientific knowledge, understanding, and the population is raised to a level to substantially reduce the fear of science? Should some minimum level scientific understanding be required to earn a college degree?
I don't know. That's a good question. It's a very good question. And I think we need to have that discussed. Maybe our education department could lead that discussion on campus. Forcing science on people generally doesn't work. We've done a really good job, or a reasonably good job, at lowering anxiety about math, for example. And I think we can take some clues from particularly our math department, which I think has been very successful in making math accessible to the campus. Their mathematical contest, which went on last weekend, I think, is a really good way of getting lots of students involved in that. And the fact that we have found the most successful teams in that have been teams of mathematicians made up with non-mathematicians as well, because the kinds of problems they try and solve through mathematics are non-mathematical problems. And that's basically a real good use of mathematics. And I think we could do that in chemistry. I think we could do that in lots of fields. So maybe we need to think of a more inclusive way of including lots of different people, of ways to lower the anxiety level, both inside and outside the classroom, because we have pressures from outside the classroom to do some strange things with science now. And I mean, we need to let some good teachers teach science, that's for sure. But that's a complicated question. I understand that, but it's a very good question too.
And our final question will be, for the next generation of students, joining the science field can be intimidating given the current public doubt of scientific practices. What advice or encouragement would you give to the youth who will eventually be at the forefront of scientific progress?
I would give them a liberal arts education. I'm a big fan of liberal arts education because there's a holistic nature to it, in which our students who go out in science do have a view of the world that is not just science. I mean, even though geeks are in these days, science geeks sometimes go off on their own deep end, and we need to understand there are people who can't do cell phones, and we need to accommodate them as well. We also need doctors who are willing to explain what they're doing to their patients, even though all of us are of different medical knowledge. Compliance is one of the real problems in medicine these days, because many people don't understand complex therapies. And well, I don't know, I've eaten lard all my life in pie crusting. I did fine, and my mother did fine. What do you mean I can't eat lard anymore? You know, stuff like that. So the broader the education is, the better off we're going to be at our level. But that's also a good question. You're asking me hard questions.
All right, with that, With that, I will say thank you to everyone for attending here today, and a special thank you to you, Dr. Warnett, for not only being our presenter today, but for everything that you do for our students here at Simpson. It's very much appreciated. Thank you all for being here and have a wonderful day.